Section 8 is two variable inequalities. So the first thing I want to point out is the fact that it's two variable, which means you're graphing on an XY axis. And the second thing I want to point out is an inequality requires you to shade. Couple of rules about graphing inequalities. The first is to graph the inequality using slope-intercept form. I'm actually going to cross out using slope-intercept form because we're also going to be doing absolute value inequalities, which do not have a slope-intercept form. The second step is to decide if the line should be solid or dotted. It is solid if it's less than or equal to or greater than or equal to. It is dotted if it's just less than or just greater than. For the shading, you shade above the line when it's a greater than or equal to. You shade below the line when it's a less than or equal to. Most important thing you need to recognize about these questions, first, is that it is an inequality, which requires you to shade. The second is that this one is a y equals mx plus b. To graph y equals mx plus b, start at the y-intercept. Our y-intercept is a positive 1, and from there, count off your slope. The slope is 4, as a fraction is 4 over 1. So I'm going to go up 4 to the right 1. When I draw on the line, be really careful. This is going to be a dashed line because it's a less than, and not a less than or equal to. This line will be dashed. For the shading, again, because it's a less than, I'm going to put my finger on the y-intercept and shade down. So I end up shading this entire area. This is called a half plane. The line or boundary line that you make creates planes, and this is a half plane that you're shading. So when it's less than, put your finger on the y-intercept and shade down. Letter B. Letter B is not solved for y, so that's actually the first step in doing this one. First thing I'm going to do is divide everybody by -1. Remember, when dividing by a negative, that less than or equal to becomes a greater than or equal to. And then simplifying the rest gives me a -1/3 x plus 4. I'm going to cloud this. It's really important that I use that one when shading and not the original. That's a straight line that starts at +4, whose slope is up 1 and to the left 3, or down 1 and to the right 3. And when I draw in the line, it's going to be solid, because the line under the inequality tells me it should be solid. Again, I've got a top half plane and a bottom half plane. The shading on this one, it was a less than, but it's actually a greater than. So put your pencil on the y-intercept, shade up. We end up shading this entire half plane. Back when we first started graphing, I said it's important that you take the graph from one end to the xy axis to the other so that shading became easier. And this is where the shading becomes easier. So number 2, I mentioned that there are going to be absolute values. Number 2a is an absolute value. That's an absolute value that has gone left 3 and down 2. So if I go left 3 and down 2, my vertex is in the third quadrant. There is no stretch or compression, nor is there a reflection. So from the vertex, I'm going to go up 1 over 1 on the right a few times, then go back to the vertex and go up 1 over 1 to the left a few times. And when I draw in the line, they're going to be dashed because it's just greater than. It said dashed and chose that anyway. When we first learned how to graph absolute values, I told you they can look like check marks as long as you go from one end of the graph to the next. And that's what's happening here. When you look for the shading, this is a greater than. So put, again, your pencil on the y-intercept and shade up. Greater thans go up. So I'm going to end up shading kind of what happens to be the top or inside of this absolute value. Make sure that when you shade, you can very clearly see the boundary line so you know whether it's dashed or solid. That's very important. Letter B is also already solved for y, and it's an absolute value. This is a line that has not moved left or right. However, there are a whole bunch of other things that have occurred. I see a reflection on the x-axis, so I better have a slope down. I see a compressed by 2/3. And I see an up 4. So I'm going to start up 4, my first point, that's my vertex. And from there, I'm going to go down 2 over 3 on one side, down 2 over 3 on the other side. And this is strictly less than, which means that this is going to be a dashed line on either side. And the inequality here is a less than. So when I look at that less than, that means I'm going to put my pencil where it crosses the y-axis and go down. So you end up shading what kind of looks to be a house. Greater than shade up, less than shade down. Something we haven't discussed in this lesson yet, it should be the case that any ordered pair I pick within the shaded region, like this ordered pair, any of them, should work in the inequality. That if I put 1, 1 into the inequality, I get a true statement. I'm going to start on the right-hand side. The absolute value of 1 is 1 times negative 2/3 is negative 2/3. So I'm just recopying each time. Negative 2/3 plus 4 is 10/3. And 10/3 is approximately 3.3. So I get 1 is less than 3.3. And that's a true statement. So I know that I'm good to go. Any ordered pair I would pick in the non-shaded region, like this one, if I put those x and y values into the inequality, I would get a false statement. True statements come from the shaded region. False statements come from the non-shaded region. Letter C is not quite ready to be a graph. I'm going to start by subtracting 2 from both sides. I get y is less than or equal to 1/2 times the absolute value of x minus 5, because the negative 3 and minus 2 are like terms. That is a graph that has been compressed by 1/2 and goes down 5. So start with the down 5 part. From there, I'm going to count off my slope of up 1 over 2 on both sides a few times. And when I draw on the line, it will be solid because there's equality to it. This is a less than or equal to, so put your pencil where it crosses the y-axis and go down. Less thans go down. You're going to shade the half plane that's below this absolute value. Letter D is not solved for y, so I'm going to do that first. First step is to subtract 4 from both sides. I'm left with negative y is less than or equal to. Be careful with the right-hand side. You can't subtract the y from the absolute value. That's a no-touching zone inside. Then I'm going to divide every term by a negative 1. I get y is greater than or equal to, watch that change there, that's very, very important. It's greater than or equal to negative absolute value of x plus 1 plus 4. Again, inside the absolute value is a no-touching zone. This has been reflected on the x-axis. It has moved left 1 and up 4. So left 1 and up 4 puts us in quadrant 2. And the reflection means our graph is going to go down. So down 1 over 1 a couple of times on this side. Go back to the vertex and go down 1 over 1 a couple of times on that side. And when you draw on the line, it should be solid because there's equality. Even though it was a less than, we're actually graphing a greater than. So put your pencil on the y-intercept, shape up. Pause the video and do the you try it.